Hello and welcome. This is Dr. Himayatullah Khan. Today I am going to discuss various types of parametric tests. Basically, there are two types of tests. Uh, Type 1 is parametric tests, and the other type of these tests is non-parametric test. Before we can do any kind of test, we will test two assumptions, that is the assumption of randomness and the assumption of normality. If these two assumptions are satisfied, then we will use a parametric test. If these assumptions are not fulfilled, then in that case we will use non-parametric test. Suppose that for certain quantitative variables the two assumptions are satisfied and we are going to conduct parametric test, then what are the types of parametric tests that we will do. So I have written for you here. The first test is one sample t-test, the second is a independent sample t-test, and the third one is paired sample t-test, and the last one is one-way analysis of variance, that is one-way ANOVA. So I will do that one by one. I will start with one sample t-test. So let me start with my data which is here. Suppose that I want to conduct some parametric test for this variable. Later on I will use these two variables. So this is salary and this is beginning salary. Beginning salary means this is the salary at the beginning of the job, and this is current salary maybe after a number of years. So uh, first I would like to conduct the one sample t-test, and I'll go to analyze, compare means, and then one sample t-test, and here it is asking me what is your test variable. Uh, Let us assume that I want to test this variable, current salary. Here I will give certain type of some kind of average value, and my assumption would be that the average is equal to that particular value. Let us suppose this is 40,000. 40,000. Now let me okay this, and it has calculated for me the t-test, one sample t-test. The first table here shows current salary. This is the number of observations. This is the average of the current salary, which is 34,420. This is the standard deviation. This is the standard error of the mean, and standard error of the mean is equal to the standard deviation divided by n under root. If you divide this value by 474 under root, then you will get this value. This table gives us one sample t-test, and the current salary one sample t-test value is minus 7.115. This is the degrees of freedom. This is the p-value, and the p-value is less than the 5%, that is 0.05. So it means that we will reject null hypothesis. So what was my null hypothesis? My null hypothesis was, uh, let me this is my one sample t-test, and my null hypothesis is h naught. H naught is that mean is equal to 40,000, and alternative hypothesis is that mean is not equal 40,000. My alpha, that is significance, level of significance, is equal to 0.05, and test statistics is one sample, sorry, this is one sample t-test, and there is computation. We will compute it, and SPSS will be used for computation purpose. My decision rule would be, if p value is less than 5%, then we will reject this null hypothesis. If p value is greater than 5%, then we will fail to reject this, and we will conclude that the mean is not equal to 40,000. So if you see here, the t value is 0.000, which is less than 5%. So we will reject null hypothesis and we will conclude that the mean is not equal to 40,000 because the actual mean here is 34,420 and our given mean was equal to 40,000. So there is difference. There is difference of 6,000 between this mean, the observed mean, and the hypothetical mean. So here basically we reject this and we conclude that the mean is not equal to 40,000 because the actual mean of this variable, the current salary, is 34,420. So this is how we do one sample t-test. This is also called univariate analysis. Let me go and do the second test, and that would be independent sample to test. So let me write here independent sample to test. Let me another one, and I will call it independent samples t test. Null hypothesis, no difference between two means, which means they are the same. Alternative hypothesis is there is difference between the two means. Level of significance alpha equals 0.05. Test state this time is independent samples t test. T test. There is computation. We will use SPSS for computation purpose, and then there is my decision rule, and decision rule is again the same. If p value is less than 0.05, then we will reject H naught, and in that case we will conclude that there is difference between the two mean. So first let me calculate or compute the independent sample t-test. So I will go to analyze and go to compare means, and this time I will click on independent samples t-test, and this is my variable of interest, and it says grouping variable. Now this time I will send gender as a grouping variable. Now gender has two categories, male and female, and basically independent sample t-test will compare the null hypothesis. It will compare the mean salary of the male and the mean salary of the females. Let me define these two groups. We have one for males and two for females, so there are two groups. Excuse me. I will continue, and then I will press OK, and after press OK I have these two tables. This is t-test, independent sample t-test. Now the first table gives us group statistics for the two groups, male and female, and the variable is current salary. So total number of observation is 474, and out of that 258 are males and 216 are females. This is the average salary of the male, average current salary of the males, and this is the average salary of the female. These are standard deviations, these are standard error of means, and here you see this is independent sample t-test, and basically independent sample t-test also assume equality of variances. Now our null hypothesis is that the variance of the current salary of the male is equal to the variance of the current salary of female. And this is test is on the basis of Leven's test for equality of variances, for which we use F-test. Now the observed p-value for the F-test is 0.000, which is less than the 5%, so we will reject this hypothesis. And when we reject this hypothesis, so we will read this one. And in front of this is the t value. So we will use this t value instead of this. If this value were greater than 5%, then we will fail to reject this hypothesis, and then in that case we will read this t value. But since we reject null hypothesis for the equality of variances, so we will read this t value which is in front of equal variances not assumed, and this t value is also significant. So it means that the average current salary of the male and female are not the same. They are quite different, and you can see they are quite different because the average current salary of the males is more than 41,000, whereas the current average salary of the females is a little more than 26,000. So there is difference between these two. So since this p value is 0.000, so my p value is equal to 0.000, which is less than 0.05. So I reject this null hypothesis and I conclude that there is difference between the two means, and you saw that the two means are not equal. That is, the average current salary of the males is different from the average current salary of the females. Now let me move to the other parametric test, and that is paired sample t-test, and for that I will create another slide here. Okay, so I'm here, and now I will use a paired samples t-test. Again, our null hypothesis is no difference between the two means. Alternative hypothesis that the two means are different. Then my level of significance is 0.05. Test statistic is pair sample t-test, and decision rule is if the observed p-value is less than 5%, then we will reject null hypothesis. If the observed p-value is greater than 5%, in that case we will fail to reject null hypothesis. So let me tell you how can we compute the paired sample t-test. Let us suppose these are the two variables. This is the beginning salary, maybe 5 years or 10 years before salary, and this is the current salary. So this is after salary and this is the before salary, and I want to see the difference between the two. So my null hypothesis is that the average of the current salary and the average of the beginning salary are the same. There is no difference. And my alternative hypothesis is that the average of this variable is different from the average of this salary. Analyze, compare means, and under compare means go to paired sample t-test. This time now I will send current salary here and then the beginning salary, and after that I will press OK, and when I press OK I get t-test. This is t-test for paired sample t-test, and SPSS computed this for me, and there are basically three tables. The first table basically gives us the comparison of the sample statistics: current salary, beginning salary. These are the average values, these are the number of observations, these are their standard deviations, and these are the standard errors of their means. And this is the paired sample correlation, that is the correlation between current salary and the beginning salary, and this correlation coefficient is significant and is very high, 0.88. This is close to 1. So close to 1 means perfect positive, and this is also positive but a little less than. This is not perfect, but it's very high correlation between the current salary and the beginning salary. Now coming to the last table here, basically we are comparing the mean of the current salary and the mean of the beginning salary. So this is here it says pair differences. Now pair differences mean this mean difference means this is the difference between the salary of current salary minus beginning salary, and this is the difference of standard deviation of the current salary and standard deviation of the beginning salary, and this is the difference of their standard means, and this is the paired sample t-test value, which is 35.036, and its p-value is 0.000. Now this means that the observed p value is less than 5%, so it means that the current salary and the beginning salary averages are different. They are not the same, and you can see from here, one is 34,000 and one is 17,000, so they are not the same. So here in this case, we will reject the null hypothesis because our observed p-value is greater than the less than the 5%. The last one parametric test is one-way ANOVA. One-way ANOVA. How can we do that? One-way ANOVA. One-way ANOVA is one step ahead of the paired sample t-test. In paired sample t-test, we basically compare the means of the two groups. But under one-way, we compare means of three groups. So let me do this.